Now see here, this is the equation of a wave. Y of x comma t is equal to a sine kx minus omega t. So this is the equation of a wave. See, this is also equation of a wave only. V is equal to Vm sin omega t, where Vm is what? Amplitude. Here A is the amplitude of the signal, and sine is the function, sine wave, and kx minus omega t. So we are not taking any propagation constant. Here k is set to be the propagation constant, and omega is the angular velocity or angular frequency. Once again, A is the amplitude, k is the propagation constant, and omega is what? Angular frequency or angular velocity. Okay, so when we write, when we go back to grade 11 or electromagnetic waves, we write 2 pi by lambda, and omega equal to, we write 2 pi by 2 pi nu or 2 pi by t. Clear? 2 pi nu or 2 pi by t. Is that clear? Omega equal to 2 pi nu or omega equal to 2 pi by t. Is that clear? So y of x comma t is equal to a sin kx minus omega t, and k is equal to 2 pi by lambda or omega equal to 2 pi nu or 2 pi by t. So that is the way we write here. Is that clear with you? Is it clear with you? Yes. Now see here. So if you look at this wave and if you look at this, these two are same. There is no phase change. Okay. So that means what? Here voltage and current. Here current and voltage both are in phase. Current and voltage both are in phase. Both are in phase. Current and voltage both are in phase. Okay. In phase means what? Angle here, phase angle is how much? 0 degrees. Phase angle is 0 degrees. Okay. Now we have one more formula. What is that? Vrms. Vrms is equal to Vm by root 2. Vrms equal to Vm by root 2 or V0 by root 2, whatever it is. Some books it is, since in some books it is Vm, in some books it is V0. Both are same. In some books it is Vm, and some books it is V0. So Vrms is equal to Vm by root 2. What is Vrms? RMS means root mean square. Root mean square. Root mean square voltage. Okay. So we can also write 0.707 Vm. We can write in this way also. Vrms is equal to what? Vm by root 2. Is that clear? Is that clear? Vrms is equal to what? Vm by root 2. That's a formula. Is that clear? Now, if you are plotting a phasor diagram now, if you draw the phasor diagram, so here what happens if you draw the phasor diagram? See, this is the voltage, and this is the current. This is the voltage, and this is the current. Okay, voltage, and the second one is current. Okay, so this is what? 0 to 2 pi, and this is omega t. Clear? 0 to 2 pi and omega t on y-axis, x-axis. Now, if you are plotting a graph like this, so what happens? This is the voltage, and this is the current. Okay, voltage and current. Is that clear? So the angle is what? Angle is omega t. Is that clear? Angle is equal to omega t. So here, if you see carefully here, so this is the current, and this is the voltage. Okay, this is voltage and this is the current. Okay, current and voltage. That line, that is the amplitude of the current and amplitude of the voltage. Is that clear? So we can write what? I is equal to, here we have the formula. I equal to Im by root 2, Im into sin omega t, and V is equal to Vm sin omega t. This is the value, and they are in phase. See, voltage and current both are in phase with each other. Got it? And look at the amplitude. The amplitude of current is less than the amplitude of the voltage. Amplitude of the current is less than the amplitude of the voltage. Once again, from the beginning, see here. See, there are three circuits, three components, what we are going to discuss, which will be connected in AC. Now, AC means, forget about that. We are here in this context. When I say AC current, it doesn't mean that wall outlet. We have wall outlet, the plug, that is AC current. That is very fatal. We cannot touch those wires. Okay. We are not discussing about that. We have a frequency generator or we have an oscillator. So there are two pins out of which it gives a output. So we can increase or decrease the frequency. The frequency of the wall outlet we cannot increase or decrease. It's fixed, 50 to 60 hertz, 230 voltage AC and 50 to 60 hertz. That's a fixed value. You cannot change that one. Okay. So we cannot play with that current. But what we are discussing here is the output of a oscillator. Means it's, if you touch, there is no shock for this one. There is no shock. Okay, like it's like a signal. It is giving a sine wave. It can give us a cos wave. It can give us square tooth wave, sawtooth wave, or square wave. Different types of pattern it can give. Okay, the signals it can give. So that we are connecting here, but it has a voltage. Suppose like a sine wave. Like see here, this type of wave. So now it has an amplitude. So the formula is what? E is equal to, if you apply Kirchhoff's second law, E is equal to IR. And we have the formula V is equal to Vm sin omega t. And Vm sin omega t equal to IR. I is equal to cross multiply, you will get this one. I is equal to Im sin omega t. From where this equation came? It came from the grade 11 waves chapter. Grade 11 waves chapter. Y of x comma t is equal to A sin kx minus omega t. From there it came. And current and voltage both are in phase. Here angle is how much? 0 degrees. Here we have Vrms is equal to what? Vm by root 2, which is equal to 0.707 Vm. And Vm, and this is V naught. Okay, RMS is what? Root mean square voltage. Is that clear? Is that clear, all of you?
So,
okay. Then we'll discuss about inductor. Please copy this one. Then we'll quickly go to the second topic, that is inductor. Then third one is capacitor. AC voltage applied across an inductor. So here, this is the circuit. AC voltage applied across an inductor. Okay, so this is what L. L is the inductor. So what is the formula? E is equal to, here, we write V is equal to what? V is equal to Vm sin omega t. Okay, the formula is what? V minus L into di by dt is equal to 0. Okay, V minus L into di by dt is equal to 0. Why L? Because voltage across the inductor. Voltage across inductor is given by what? Voltage across inductor. Voltage across inductor is what? Is minus, what is that? L into di by dt. L into di by dt. Voltage across inductor is given by L into di by dt. So what we are doing now? This voltage minus this voltage. This voltage minus this voltage equal to 0. Now we'll simplify this one. What is that? L into di by dt is equal to what? V. Okay. So then what happens? Di by dt is equal to what? V by L. Okay. Di by dt is equal to V by L. Now what is that? Di by dt is equal to what? V is equal to Vm sin omega t. V is equal to Vm sin omega t divided by L. Okay. So then di by dt is equal to what? Is equal to Vm by L into sin omega t. Vm by L into sin omega t. Now we'll multiply, we'll integrate it now. Okay, we'll integrate it with respect to t. Did you understand? Once again, see the voltage, this voltage minus this voltage equal to 0. But voltage across the inductor is what? L into di by dt. So V minus L into di by dt equal to 0. L into di by dt is equal to V. Di by dt is equal to V by L. Okay. What is V? V is equal to Vm sin omega t. And that is what? Vm by L into sin omega t. Okay. Now we will integrate it. Okay. So how come we integrate? Integration of di by dt into di is equal to what? Vm by L integration of sin omega t into di. Okay. Sorry, sin omega dt, sorry, with respect to t. Is that clear? We integrated on both the sides with respect to dt. Now what
yes,
will happen? Now this will become integration of this will become I. Integration of the whole thing is I, which is equal to Vm by L. Sin omega t integration is minus cos omega t. Okay. See, we have integration of sin x dx is minus cos x. Sin integration is minus cos. So minus cos omega t divided by omega plus c. Is that clear? V by L. So what do we write here? Vm by I is equal to what? Vm by L minus sin omega t is equal to minus cos omega t divided by omega t integration is omega. That should be divided. Derivation is omega. That you have to divide it. So what did we get now? So we got here I is equal to what? I is equal to minus Vm by omega into L into cos omega t plus c. Minus Vm divided by omega L into cos omega t plus constant. Okay. Now, so what is cos omega t now? Minus cos omega t can be written as minus cos omega t can be written as sin omega t can be written as sin omega t minus pi by 2. Okay. This can be written as sine omega t minus pi by 2. So what is the answer now? I is equal to Im sine omega t minus pi by 2. Are you understanding? I is equal to Im sine omega t. So so what is Im? Im is equal to, we are writing here, Im is equal to, see the whole thing. Okay, Im is equal to what? Im is equal to Vm by omega L. Okay, Im is equal to Vm by omega L. So here, what is omega L? Omega L is said to be inductive reactance. Omega L is said to be the inductive reactance. Omega L is said to be the inductive reactance. So what is XL here? XL is written as omega L. Okay, XL is said to be the omega L. So like as I told you, what is reactance? Reactance. Like suppose reactance in electricity is similar to impulse response in light chapter. Impulse response means suppose the room is dark. Suddenly you on the light. So you'll blink your eyes. Okay, you close your eyes for a moment and then slowly you open it. Okay, you slowly open it. Means means when the eyes were not allowing the eyeball or whatever the retina, the pupil was not allowing the light to pass through. It blocked for some time. Okay, for a fraction of time. So there's an impulse response. Means you know what is happening here. It is responding to the that is impulse response means what? Impulse response means replying to the input. So here we have reactance. So when the current wants to pass through the component has stopped for a moment. That is said to be inductive reactance. So if it is inductor, it is inductive reactance. If it is capacitor, then capacitive reactance. So what happens is it is blocking for it. It's like acting like a resistor. So that is omega L. Omega L is written as XL. But XL is measured in what? Unit of XL is what? This unit of this is omega. Means unit of this is ohms. Okay. So XL is equal to omega L. So Im is equal to what? Im is equal to Vm by XL. Im is equal to Vm by XL. Okay. So XL is directly proportional to L, and XL is also proportional to frequency. Okay, it is also proportional to frequency. Inductive reactance is directly proportional to the inductor value, also proportional to the frequency value. Is that clear? And here what happens? I will draw the that is a waveform. Is that clear? Once again, see from the beginning. This circuit from the beginning. See what happened. This is the inductor and this is the input. Okay. So input voltage. So V is equal to what? Vm sin omega t. This is the input voltage what we have given. V minus the voltage across this is what? L into di by dt. Cross multiply. Bring this fellow on the other side. Plus minus will become plus and cross multiply this one. So di by dt is equal to what? V is equal to Vm sin omega t divided by L. Then here this is Vm by L into sin omega t. Then integrate it dt. Okay. So Vm by L into dt. So I is equal to what? Integration of this is I is equal to Vm by L. Sin omega t is minus cos omega t divided by omega plus c. So minus Vm by omega L into cos omega t plus c. So here minus cos omega t is equal to sin omega t minus pi by 2. Okay, that means you can convert cos into sin in this way. Then we are writing in the place of this, I write I, and then this is Im. Then minus cos omega t can be written as sin omega t minus pi by 2. Now, so what is that? Im is equal to Vm by omega L. Omega L is said to be the inductive reactance. So XL is equal to what? Omega L. Okay. And Im is equal to Vm by XL. And is that clear? So XL is what? Inductive reactance. Okay. Okay. Xm is equal to, once again. So XL is equal to what? XL is said to be inductive reactance. Clear? Is this clear, all of you?
Yes, sir.
Yes, Moksha and